So for our project, we did water resistance spray.
We are testing which water-resistant spray is the most effective and why. We decided to research different water-resistant sprays because the information is useful in many everyday situations. As frequent commuters in New York City, we often have to deal with a lot of rain and slush, so we thought it would be interesting to research a way to avoid getting wet.
So what makes something hydrophobic? And being hydrophobic just means something is waterproof and water does not sink into the material. So one thing that can make something hydrophobic are like tiny little spikes on the surface of the material, and the gaps between the spikes are too small to let water between them, but there is enough room to let air molecules pass through, keeping the material breathable, meaning that air can pass through. So it doesn't seal you inside. Some materials also have an oily coating because oil doesn't mix with water, so the material won't get past the oil and it won't get wet. Oily coating can sink into the material, so it may be waterproof but not oil-proof because the water can still sink into the material, or the oil can.
So Ezra showed a picture of a 3D model before of the spikes, and this is more of a 2D diagram. So as you can see, there's a water droplet like sitting above the spikes and it's not passing through. And you can also see the space in between the little spikes, letting the air come through, so it's a breathable material. But the space is too small for the water droplets, so only air can pass through.
So our procedure, so we started by cutting an 8x8 centimeter square of material, and then we weighed that, and that was our, and that with the water was our control, but I'll explain that in a minute. So we used 4 different materials: cotton, nylon, leather, and polyester. And for each one, we cut an 8x8 centimeter square of material, and then we sprayed it with each spray, and then we weighed that. So then after that, we saw a pattern, which was that Scotchgard added about 0.1 grams, Never Wet added about 0.2 grams, and Granger's added about 0.3 grams to the mass of just the square alone. After that, we poured 4 milliliters of water onto the sprayed piece of square material, and we gave it a chance to, if the spray didn't work, soak into the material for 40 seconds. And then we would kind of hold it up like this, the square of material. And if the spray worked, all the water would drip off. And then we would weigh that square of material. So if the material had additional mass, that means that the material absorbed the water and the spray wasn't effective. And if it didn't gain mass, then the spray was effective in keeping water out of absorbing from the material.
Okay, so we concluded that our data was precise because we followed the same procedure, the same steps, and we didn't really change it, so it made our data consistent. Even though hopefully it was accurate, but we know it's precise because we stayed the same. We did the same thing every time. And the brand of spray was our independent variable, and the mass change of the material after being tested was the dependent variable.
So this is our graph that shows the different materials and our data that we collected. So you can see the cotton is the blue, the polyester is the red, the nylon's the yellow, and the leather is green. And we did a control without the spray so that you could compare it to see how well these sprays, all of them did actually work. And you can see Never Wet, the gained mass is the slightest. So it was the most effective because it absorbed the least amount of water and it all dripped off when you picked it up. And then Scotchgard. Scotchgard also didn't absorb very much, but it absorbed a little bit more than Never Wet. And Granger's came after Scotchgard, although Granger's did perform better than Scotchgard on the polyester.
The most effective spray was Never Wet, which is the winner.
So after conducting all of our research and after finishing to collect our data, our conclusion was that Never Wet was the most effective spray. And in our data, we saw that the average mass increase for Never Wet was about 1 gram, where Granger's and Scotchgard ranged from 2 to 4 grams. Throughout almost every material, Never Wet absorbed the least amount of water and had the least mass increase. So we had a couple different errors and limitations. So this is actually more of a limitation. We followed the manufacturer's directions on the sprays. So if you read the label on the spray, some of the labels basically said that you had to put the material under water and get it wet before you put the spray on and then spray it while it was still like damp. This affected our data because in our procedure, we had to weigh the material after it had been sprayed. But if you clean it first, the water that you cleaned it with is still in the material, and that would add substantial mass in each case.
Okay, so our second error is that when we got the leather, it was 4 centimeters, and we had to make it into an 8 by 8 centimeter square. So we glued it together with a strip of hot glue in the middle. And so to ensure that our measurements would be correct, we weighed a strip of hot glue on a triple beam balance and then subtracted that from the total mass of the glue and the 2 pieces of leather. And we thought this was the most effective way to do this to make sure it's as accurate as possible. But we don't know it's not precise because we don't know how much every specific inch of glue there was. So it could change our data a little.
Our third error was that in our first round of trials, we counted 40 seconds ourselves in our out loud instead of using a timer on the computer, making our data possibly inconsistent.
These were our references.
Yeah.
Okay, questions?
Can you guys see the questions list? Are there questions from your audience? So I see a reaction from Franny. If you have a question, do you want to raise your virtual hand? I can start us off with a question. If you guys were to have more time and to perform a follow-up step to this experiment, what would you do, or what would that look like?
Originally, our final step was going to be we were going to try to make our own spray, and we were going to look at the price of each spray and see which one, to the dollar, was most worth it. Because even though Never Wet was the best, we actually didn't have time to actually go and look at the prices of each one and look at come up with a separate procedure to decide how from the spray to the price of it to see whether it was worth it to buy the best spray. And then we were going to try to make our own and see if we could make one for the cheapest and the most effective.
And another step that we were thinking of doing after this is we could have tried to look further into the ingredients of each spray, but we found them extremely hard to come by. But we were thinking about calling or emailing the companies to say we're doing a science project and we're wondering what some of the main ingredients are. And if we did that, that would just help us to better understand why Never Wet was such a clear winner.
And how sorry, why don't you go to other students and then I'll.
Tallulah?
So you said for certain of the sprays, then you had to make them damp before you sprayed them. Do you remember for which ones they were? How do you think was that for Never Wet, or was it for one of the ones?
It was for Granger's, and that was actually the spray that in the pattern that gained the most mass, which made sense to us because when we weighed it after we sprayed it, and for Granger's we had to clean it, so for that step of the procedure it gained the most mass, which made sense because the water did add substantial mass.
Okay, thank you.
Jude.
Did you guys take into consideration the recommended amount of the product, like that says in the directions on the can or the squirt bottle?
Yeah, most of the sprays said like spray once or spray like a couple times until like fully soaked, and we just followed the directions on the thing.
Great.
We actually did that like purposefully because part of our experiment was to try to use it as like an everyday as an everyday person who buys the product.
Mm-hmm, mm-hmm.
And maybe like it could be part of how effective it is, or like if you want to buy it, like if it's super hard to apply or needs to dry for like a few weeks, then maybe it's not such a great thing to buy just for like a shirt.
I'm curious also for everyone how you decided on these specific sprays themselves. Was it what you could access, or was it based on popularity? I know that sometimes we're limited with what materials we were able to actually order into the lab, but if you guys, was there any research done on which materials are most popular in terms of common sprays to use for to make materials water resistant?
Yeah, we researched what is the most like accessible spray like you could find at a convenience store or hardwood store or whatever. And we didn't want it being like so expensive, like 50, 60 bucks. We tried seeing if it's like affordable convenience sprays that people can actually like find in a store and they can use at their home.
And Never Wet and Scotchgard were like two easy ones that were like definitely the leading companies, but we wanted to test some other sprays. And Granger's, there were a few others like it that weren't so popular, but we found them and we decided to test Granger's.
We also didn't want to buy like an $100 spray. Like I don't even know if they make those, but we took like price into consideration because that's what most people would do when they were buying these.
Right, we weren't going to buy something industrial grade.
Does anyone else have any questions?
Fantastic. Okay, definitely a clap from me as a follow-up. That was excellent, excellent, especially being the first. Remarkable, and I'm actually in shock. We had no technical issues, so what a gift that was.